Yes, look, my dear students, now we are discussing the types of rate of reactions. In that first one, in the types of rate of reactions, we have to discuss the first one. It is average rate of reaction. Actually, the rate of reactions are two types, such as average rate of reaction, instantaneous rate of reaction. So, what is the rate of reaction? Rate of reaction we have discussed, that is the rate of reaction we are discussed, that is the change in the concentration of reactant or product by unit of time is called as rate of reaction, right? So now the types of rate of reactions, in that first one, average rate of reaction. Average rate of reaction. Average rate of reaction. See, what is the average rate of reaction? Average rate of reaction, nothing but rate of reaction can be measured over period of time, or the rate of reaction can be measured in between the two time intervals is called as average rate of reaction. For example, from morning 8 to evening 5 o'clock, one of the reaction is going on. So at the middle time, it is from 9 o'clock to 10 o'clock, what is the rate of reaction? That we call average rate of reaction. In a certain period of time, what is the rate of reaction in case if it is measured? That we call average rate of reaction. So average rate of reaction, nothing but the rate of reaction, can be measured, can be measured over period of time, over period of time, or between two time intervals, between two time intervals is called average rate of reaction. Average rate of reaction. See, average rate of reaction generally we can express or we can denote by the R bar. So average rate of reaction, average rate of reaction, average rate of reaction can be denoted by R bar. See, look at R bar equals to, that is average rate of reaction equals to change in the concentration divided by change in the time. So change in the concentration, nothing but so concentration of C2 minus C1 divided by then delta T. So that is delta T, nothing but T2 minus T1. T2 minus T1 we can take. See, look at in case rate of reaction, if you take for the reactants and products with respect to the reactants and with respect to the products, if you take. First, consider a reaction, that is reactant can be converted into product. This is one of the reaction. For this reaction, with respect to reactants, in case if you take rate of reaction with respect to reactants, if you draw the graph for concentration of reactant versus time, reactant versus time. So we know that with respect to the reactants, concentration of reactant will be decreases. With respect to products, concentration of product will be increases. This increases or decreases, whatever we are discussing, that is exponential. See, look at my dear students, here we are taking, that is the decreases like this. So in case if you take at this point at a time T1, then rate of reaction, that the concentration is C1. Then at time T2, so that is T2, that is concentration is C2. See, look at here, in this case, C1 is, which case? In the reactant case, C1 is greater than C2. C1 is greater than C2. So average rate of reaction, in case if you want to find out, average rate of reaction equals to minus C2 minus C1 divided by then T2 minus T1 have to take. So for the reactant case, we have to mention minus. This minus is indicating, decreasing the concentration of reactants. But the value we can get positive value only. So always rate of reaction, either average rate of reaction or instantaneous rate of reaction, it is always positive quantity. Remember, my dear students. Then with respect to products, if you take, so with respect to products, rate of reaction, in case if you want to measure, then look at the graphs. So product concentration versus time, if you take, then I told that product concentration from the 0 to, it will be increases, exponentially increases. So exponentially increases like this. Then at a time T1, if you take, at a time T1, then at a time T2, then concentrations if you take, then C1 here, then C2. Then you can observe in this case, the C2 is greater than that of C1. But in this case, C1 is greater than that of C2. So here, when you calculating the average rate of reaction, so need not to mention minus C2. So need not to mention the minus. So simply we can take C2 minus C1 divided by T2 minus T1. Understand, my dear students? So this is average rate of reaction in the certain period of time, either with respect to the reactants or either with respect to the products. Rate of reaction we can measure. So this is what we call average rate of reaction. Average rate of reaction can be denoted by R bar. Clear? Understand, all of you? See, look at average rate of reaction with respect to the reactants and products. If we take with respect to the reactants and products, if you take, see, that is average rate of reaction equals to minus change in the concentration of reactant divided by change in the time. With respect to the products, if you take, so simply delta concentration of P divided by, so delta T we are expressing. So expression of the rate of reaction for the average rate of reaction. So reactants, when we are considering, negative sign you have to take. Sir, when we have to consider the products, positive sign you have to take. So negative sign, if consider reactants. The positive sign, consider products. But overall rate of reaction always, rate of reaction always positive quantity. Clear, my dear students? So the positive value ne vastundi, rate of reaction anedi manam ela measure chesina kuda positive value ne vastundi. So remember one of the thing here, then increasing the concentration of reactants or products with respect to time in the zero order reactions, it is in the linear manner. So note that point is very important. Note. So what I told, for zero order reactions, decreasing the concentration of reactants or increasing the concentration of products is in the linear manner. Other order reactions, if you take, so increasing the concentration of decreasing the concentration of reactant or increasing the concentration of products are exponential manner. So these two observations you have to observe. What I told, for zero order reactions, decrease in concentration of reactants or increase in concentration of products are in linear manner. So how it is linear manner, how it is, that we'll discuss. For other order reactions, if you take for other order reactions, decrease in the concentration, of reactants or increase in the concentration of products, that is products is exponential manner. Yeah, so this is exponential manner I told, this is linear manner I told, how it is. So when we are drawing the graph in between the reactants of concentration versus time, or product concentration versus time, for the zero order reactions, how the graph will be present, that we'll discuss. Then other order reactions, how the graph will be present, that we discuss. See, my dear students, for zero order reactions, the decrease in the concentration of reactants or increase in the concentration of products, linear manner I told, linear manner for zero order reactions. Look at, for zero order reactions, if we take, consider reactant can be converted into product. Sir, with respect to reactants, if you take reactants, if you take, see, with respect to reactants, reactant concentration versus time, if you take, reactant concentration versus time, if you take, then it's a decrease in the concentration of reactant like this. Then, sir, with respect to, this is first one, with respect to products, you take, with respect to products, if you take, the graph for this is the concentration of product versus time, if you take, my dear students, then product concentration should be increases, right? So that is also in the linear manner. So graphs you can get linear. So graph you can get a straight line. For the zero order reactions. For other order reactions, see, look at for other order reactions nothing but other order reactions ante, sir, first order, second order, third order, so all these reactions, it is exponentially decreases or exponentially increases. Exponential ga decrease avadam kaani, exponential ga increase avadam kaani jarugutundi. So consider a reactant can be converted into product. Then first one we are taking with respect to reactants if you take, then concentration versus time, concentration of reactant versus time if you take, exponentially decreases. Then second one, with respect to products if you take, so for the other order reactions, exponentially increases. The product concentration should be exponentially increases like this. Clear, my dear students? So this is for other order reactions, these two. Then these two for zero order reactions. Clear? Yes, graphs for the rate versus time for the zero order reactions, rate concentration versus time for the other order reactions we are discussing. Now second, instantaneous rate of reaction. This average rate of reaction. We are discussing the average rate of reaction, how we are taking. Instantaneous rate of reaction, second one. So what is the instantaneous rate of reaction? Instantaneous rate of reaction ante enti? Second one is what? Instantaneous rate of reaction. Rate of reaction. So what is the instantaneous rate of reaction? Rate of reaction can be measured. Rate of reaction can be measured. Rate of reaction can be measured at particular instant time is called as instantaneous reaction. So rate of reaction can be measured. Rate of reaction can be measured at particular instant time. Particular instant time is called instantaneous rate of reaction. Instantaneous rate of reaction. Remember, my dear students. So this is instantaneous rate of reaction. So instantaneous rate of reaction, that is rate instant, even it is, so change in concentration of reactant divided by change in the time. Once with respect to reactants we are taking here, you have to take minus sign, negative sign. Then with respect to products, if you take, then product, then divided by time you have to take. So actually the rate of instant rate of reaction can be calculated by tangent method. So rate of reaction can be instantaneous. Instantaneous rate of reaction can be measured by tangent method. Tangent method. What is the tangent method, man? So actually, so rate of reaction with respect to reactants, concentration versus time if we take, this is what? Concentration of reactant versus time if we take. Look, my dear students, what I am telling to you. So this is always the graph exponentially decreases in case if you take any other order reactions except zero order. So here in case at particular instant time, oka time దగ్గర at particular instant time in case if you take for this. So ఈ instant time దగ్గర మనం calculate చేయాలంటే, sir, we have to draw one of the line which is directly attached to the particular point. So based on that, we can say that concentration and time. So that is we call tangent method. Even with respect to products, with respect to products if you take, then what is the graph for concentration of product versus time, man? What is the graph? Exponentially increases, right? Exponentially increases. So in case at a particular time, what is the concentration? What is the concentration increases or decreases? For the products increases. Then rate of reaction at a particular concentration at the point. So if you draw that, then you can get it is the concentration, how much is increased. So based on that, we can find out. This we call it as a tangent method. Tangent method find out cheyadaniki particular instant time దగ్గర rate of reaction ni find out cheyadaniki danni instant rate of reaction anna. Instant rate of reaction ni find out cheyadaniki use chese method ni emantunna tangent method. So tangent method is used for the instantaneous reaction. Then so average rate of reaction ni find out cheyadaniki general ga exponential method, so that we can use. Clear, my dear students? Yes, note down this. Then next what will be there, that we'll discuss. I am Rohan Dev from Sri Chaitanya Mandya. Hi Rohan Dev, how are you? Yeah. I remember. Good evening. Yeah, next point we have to discuss. Sir, here the types of rate of reactions we are discussing. One is average rate of reaction, one more instantaneous rate of reaction. Average rate of reaction, instantaneous rate of reaction can be measured by using tangent method that we are discussing. Now, what we have to discuss? Sir, average rate of reaction, ఒక రియాక్షన్ కి యావరేజ్ రేటు ఇన్స్టాంట్ రేటు రెండిటిని రిప్రజెంట్ చేయాలంటే ఎలా రిప్రజెంట్ చేస్తాం? ఫర్ ఎగ్జాంపుల్, కన్సిడర్ ఏ రియాక్షన్. Consider a reaction. Consider a reaction. So that is the A plus B gives rise to C if we take. So average rate of reaction we can say that is R bar, right? So R bar, it is equals to, then with respect to A, with respect to B, in case if you want to represent average rate of reaction, how can you represent? So minus, you have to take the negative sign for reactants, consider. Positive sign for product consideration. So reactant, then delta concentration of A divided by, then delta T with respect to A. Then with respect to B, how to take, ma'am? Then it is equals to minus delta concentration of B, then divided by delta T, then equals to, then with respect to C, how to take? It is a product, so need not to take negative sign, so positive sign, so that is delta C divided by, so delta T. Sir, same in case rate instantaneous, that is instantaneous rate of reaction, how can you represent? It is equals to minus D, then concentration of A divided by dt. It is equals to minus dB, then concentration of B divided by dt, then equals to, need not to take negative sign here, then D concentration of C divided by dt you can take. So this is average rate of reaction, this is instantaneous rate of reaction, we can represent like this. So representation or express the rate of reaction, how can you express, that we'll discuss now for the other all reactions. So before going to other all reactions, what are the important points are required for express the rate of reaction, that we have to discuss. So here, to express the rate of reaction, whenever the rate of reaction we are considering, so we have to calculate for only 1 mole of reactants or 1 mole of products. Clear, my dear students? So rate of reaction always measured for 1 mole of reactants or 1 mole of products. That is the first point you have to remember. The second point, in case rate of reaction can be measured for the individual reactants or products, it is does not depends upon the stoichiometric coefficients. Okay, so rate of reaction only depends upon the stoichiometric coefficients, but individual reactants and products, it does not depends. That is the second point. Then last point, rate of disappearance of reactants or rate of appearance of products do not depends upon the stoichiometric coefficients. Clear? Understand? Yes, note that point, all this. So what I am telling, So express the rate of reaction. So types of reactions we have seen. Express the rate of reaction. Express the rate of reaction. To express the rate of reaction, first you have to remember during the rate of reaction. So during the rate of reaction, sir, with the progress of time, concentration of reactants decreases, then you have to take negative sign. Concentration of products increases, we have to take positive sign. So first, rate of reaction with the progress of time, with the progress of time, concentration of reactants decreases, you have to take negative sign. Then concentration of products increases, you have to take positive sign. So above one is negative sign, the below one is positive sign. Rate of reaction with the progress of time. So reactant తీసుకున్నప్పుడు నెగటివ్ సైన్ ఇచ్చేయాలి, ప్రోడక్ట్ తీసుకున్నప్పుడు పాజిటివ్ సైన్ ఇచ్చేయాలి. ఫస్ట్ పాయింట్ ఇది. While expressing the rate of reaction, it happens. Then second one what I told. Rate of reaction while expressing the rate of reaction. So rate of reaction, it is depends upon the stoichiometry coefficients. So rate of reaction can be measured always for 1 mole of reactants or 1 mole of products. Rate of reaction can be measured always for 1 mole of reactants, 1 mole of reactants or products, 1 mole of reactants or products. So rate of reaction ni find out చేసేటప్పుడు, సో రేట్ ఆఫ్ రియాక్షన్ ని ఫైండ్ అవుట్ చేసేటప్పుడు 1 మోల్ ఆఫ్ రియాక్టెంట్స్ లేదా 1 మోల్ ఆఫ్ ప్రొడక్ట్స్ మాత్రమే రేట్ ఆఫ్ రియాక్షన్ ని మెజర్ చేస్తాం. ఎక్స్ప్రెస్ చేసేది కూడా అలా ఎక్స్ప్రెస్ చేస్తాం. సో రేట్ ఆఫ్ రియాక్షన్ ఇస్ డిపెండ్స్ ఆన్ rate of reaction depends on stoichiometric coefficients. Stoichiometric coefficients in the balanced chemical reaction. So in balanced chemical reaction. See, last point. So remember the rate of disappearance of reactants, the rate of appearance of products. Rate of disappearance of products, rate of disappearance of reactants are rate of disappearance. The concentration decrease అవుతున్నప్పుడు సో అపియరెన్స్ తగ్గిపోతా ఉంది. రేట్ ఆఫ్ డిసపియరెన్స్ వి కాల్. సో డిసపియరెన్స్ ని సరే ఇంకో రకంగా కూడా ఏమనొచ్చు అంటే కన్జంప్షన్, రేట్ ఆఫ్ కన్జంప్షన్, రేట్ ఆఫ్ కన్జంప్షన్ or rate of disappearance, both are same. Rate of disappearance or rate of consumption and rate of appearance say rate of disappearance and rate of consumption of reactants మనం తీసుకుంటాం, ఇది reactants కి తీసుకుంటాం. Then and rate of appearance or we call it as rate of formation, rate of disappearance, rate of appearance ని rate of formation అని అంటాం. సో ఇది products కోసం ఇచ్చేస్తాం. సో products are do not depends on stoichiometric coefficients. So remember, my dear students, all these 4 points if you remember, then you can express the rate of reaction very clearly. So what I told, rate of reaction with the progress of time, concentration of reactants decreases, so that we have to use negative sign. Concentration of products increases, so that you have to use positive sign. Okay, rate of reaction can be measured always for 1 mole of reactants or 1 mole of products. Then rate of reaction depends upon the stoichiometric coefficients of balanced reaction. The next, rate of disappearance, or we call the rate of consumption of reactants, and rate of appearance or rate of formation of products are do not depends upon the stoichiometric coefficients. ఇది stoichiometric coefficient మీద depend అవ్వదు. So how it is? So if you take one of the reaction, it will be understand very clearly to you people. So now we'll see one of the reaction. One of the reaction we'll see. So in general reaction we are taking. So that is 2A plus 3B gives rise to C. This is one of the reaction. So express the rate of reaction for this. Express the rate of reaction and rate of disappearance of reactants, then rate of appearance of products, if you take. See, look at my dear students. Then rate of reaction, ROR, rate of reaction, if you take. So here both are reactants. Consideration, we have to use negative sign, right? So negative sign minus, then D into, so minus 1/2 you have to take. So minus 1/2. So D into concentration of A divided by dt. It is equals to minus 1/3 dB divided by concentration of B divided by dt. In case with respect to C, so need not to use positive sign. Even stoichiometric coefficient also not there. So simply we can write it as dC divided by then dt like this. So these are the rate of reaction expression. So ఎలా తీసుకున్నాం? So 1/2 then 1/3 తీసుకున్నాం. ఎందుకు అలా తీసుకోవాల్సి వచ్చింది? Sir, with respect to A, with respect to B, with respect to C, rate of reaction equal ga undali ante, then you have to consider for each and every reactant and product is equals to 1 mole. So ఇది 1 mole తీసుకున్నాం కాబట్టి ఇది కూడా 1 mole తీసుకోవాలంటే divided by 3 చేస్తే then you can get 1 mole. So ఇది divided by 2 చేస్తే then you can get 1 mole. So that's what here divided by 2 divided by 3 we are taking. So it is already 1 mole, so need not to divide by this. Next, rate of disappearance of reactants అన్నాడు. So rate of disappearance, ROD అంటే rate of disappearance of A in case if you take with respect to A. that is equals to, then so minus dA concentration divided by dt. So why sir? So why 1 by 2 తీసుకోవట్లేదు? So because I told that rate of disappearance కానీ rate of appearance కానీ స్టాయికియోమెట్రీ కోఎఫిషియంట్ మీద డిపెండ్ అయి ఉండదు. సో ఇండివిజువల్ రియాక్టెంట్స్ కాబట్టి ఇండివిజువల్ రియాక్టెంట్స్ తీసుకున్నప్పుడు ఇది స్టాయికియోమెట్రీ కోఎఫిషియంట్ మీద డిపెండ్ అయి ఉండదు. దెన్ రేట్ ఆఫ్ డిసపియరెన్స్ ఆఫ్ బి తీసుకున్నా కూడా దట్ ఈస్ ఈక్వల్స్ టు మైనస్ డిబి డివైడెడ్ బై సో డిటి అని తీసుకోవచ్చు. దెన్ రేట్ ఆఫ్ అపియరెన్స్ ఆఫ్ సి తీసుకున్నా దెన్ ఈక్వల్స్ టు సార్ హియర్ పాజిటివ్ సైన్, the positive sign dc divided by dt. Understand my dear students? So this is rate of disappearance of A, then disappearance of B, then appearance of A. So you have to represent like this. Then one more reaction I'm taking, that is second reaction. Sir, in case N2 plus 3H2 gives rise to 2NH3, one of the reaction is there. So this reaction ki first rate of reaction, then rate of disappearance of N2 and H2, the rate of appearance of NH3 if you take. So first we are representing the rate of reaction. So rate of reaction equals to, my dear students, so minus dN2 concentration divided by dt. So need not to divide with any number because it is already 1 mole will be there. So దీన్ని 1 mole తీసుకురావాలంటే ఏం చేయాలి? minus 1 by 3 dH2 concentration divided by dt concentration equals to, this is so 1 by 2 into, see look at dNH3 concentration divided by then dt concentration. So this is the rate of reaction. So rate of reaction అనేది స్టాయికియోమెట్రీ కోఎఫిషియంట్ మీద డిపెండ్ అయి ఉంటది. బట్ రేట్ ఆఫ్ డిసపియరెన్స్ లేదా రేట్ ఆఫ్ అపియరెన్స్ అనేది స్టాయికియోమెట్రీ కోఎఫిషియంట్ మీద డిపెండ్ అయి ఉండదు. So now we have to discuss about the rate of disappearance of N2 and H2. Rate of disappearance of say N2 if you take N2 తీసుకున్నాం. సో N2 ఎలా డిసపియరెన్స్ మెన్షన్ చేస్తాం? సో మైనస్ dN2 డివైడెడ్ బై dt. సో స్టాయికియోమెట్రీ కోఎఫిషియంట్ మీద డిపెండ్ అయి ఉండదు. సో రేట్ ఆఫ్ డిసపియరెన్స్ ఆఫ్ ఇన్ కేస్ H2 if you take, it is equals to minus dH2 concentration divided by dt. Then rate of appearance of ammonia if you take NH3, then appearance, so even ఇక్కడ స్టాయికియోమెట్రీ కోఎఫిషియంట్ మీద డిపెండ్ అయి ఉండదు. దెన్ ఏమంటాం దాన్ని? సో dNH3 divided by then dt. See, look my dear students, so all these expression of rate of reaction. So one more reaction we'll discuss. Which is given in the NCERT textbook. So one of the reaction is given in the NCERT textbook, that is Br minus plus BrO3 minus plus 6H plus. So it gives rise to Br2 plus 3H2O. They are mentioned like this. So this is the reaction. So for this reaction, how to represent the rate of reaction? Rate of reaction ni ela represent chestam. So rate of reaction is depends upon the stoichiometric coefficient, right? So rate of reaction equals to minus dBr minus divided by then dt equals to then minus dBrO3 minus divided by dt. It is equals to minus 1 by 6 you have to take. Depends upon the stoichiometric coefficients, right? So H plus ion concentration divided by dt. It is equals to then dBr2 concentration divided by dt. It is equals to, so 1 by 3 positive sign you have to take, positive sign, negative sign kaadu, products ki positive sign తీసుకోండి. Then dH2O concentration divided by dt you have to take. Clear my dear students? So in case rate of disappearance of reactants, then rate of appearance of products if you take. So rate of disappearance of Br minus if you take, then you can take dBr minus divided by dt. Then rate of disappearance of BrO3 minus equals to dBrO3 minus divided by dt. Then rate of disappearance of H plus ions if you want to take. Then, so all these disappearance negative sign you have to take. D H plus ion concentration divided by dt. So stoichiometry coefficient unna disappearance lo manam teeskovatledu because it won't depends upon the stoichiometric coefficients. Then rate of appearance of Br2 if you want to take Br2. Then how can you take, man? So D concentration of Br2 divided by dt. Then the rate of appearance of H2O in case if you want to take, that is equals to, look at the rate of disappearance of Br minus is there, BrO3 minus is there. So disappearance anni kuda disappearance ఇప్పుడు Br minus యొక్క disappearance BrO3 disappearance కి ఈక్వల్ అవ్వదు, అట్లే Br minus then H plus కి ఈక్వల్ అవ్వదు. But rate of reaction can be equal for all because rate of reaction we can measure for only 1 mole of any reactant product. So rate of appearance of H2O తీసుకున్నప్పుడు stoichiometric coefficient ఉన్నా కూడా మనం దాన్ని తీసుకోం. So dH2O divided by dt like this. Understand, my dear students? So this is express the rate of reaction. So based on this, some of the problems, numerical problems we'll do. Hi sir, Srinivas sir, how are you? Say some of the numerical problems based on it. So one of the question, look at, in a reaction concentration of reactant A changes from, in a reaction concentration of reactant A changes from 0.2 molarity to 0.15 molarity. 0.15 molarity. Then in 10 minutes. So what is the average rate of reaction during the time interval? What is average rate of reaction? Average rate of reaction during time interval. Time interval, they're mentioned like this. So this is the question. Look at, my dear students. So average rate of reaction, it is equals to then minus of C2 minus C1 divided by then T2 minus T1, right? So C2 concentration, what will be there, man? C2 0.15 minus 0.2 divided by, say, T2 10 minutes, then minus 0 from 0 to 10 minutes. Then you can get it is, so 0. So that is 0 point minus of minus 0.05, then divided by 10 you can take. So minus of minus is what? Plus, then 0.05 divided by 10, that is equals to, we can take it as 0.055 into 10 to the power of minus 2, then divided by 10, you can take it as 5 into 10 to the power of minus 3, right? So this is what you have to take. It is there in the minutes, right? So units, what you have to take? Mole liter inverse, concentration is mole liter inverse, then minute inverse. So time minutes lo unte minute inverse ani teeskovali, time seconds lo unte second inverse ani teeskovali. So then one more question we'll see, my dear students. So one more question. So that is a chemical reaction is given below. Second one, a chemical reaction is given below. A chemical reaction is given below. That is 4A plus B is sliced to 2C. At particular time, at particular time, if B is being consumed at, if B is being consumed at a rate of 0.25 molarity, then second inverse. Then calculate number 1, rate of disappearance of A, rate of appearance of C. Rate of disappearance of A. Then number 2, rate of appearance of C. So this is the question. Look at the question carefully, my dear students. Rate of disappearance of A and rate of appearance of C, both are given. See, first whatever the reaction is there, so note the reaction, all of you. So note the reaction. So what is their reaction, man? That is the 4A plus B gives rise to C, 2C will be there. So rate of reaction ela represent chestam first. Rate of reaction equals to minus 1 by 4 into dA concentration divided by dt. It is equals to dB concentration divided by dt. Then it is equals to 1 by 2 into dC concentration divided by dt. See, in this question, one of the point is mentioned. B is consumed at the rate of 0.25 molarity second inverse. That means this value is mentioned. Once this value is mentioned, this is equals to this. That means this is equals to rate of reaction also. Clear? So we can say that rate of reaction, it is equals to 0.25 molarity second inverse. Clear? Understand? Then what they're asking? Rate of disappearance of A. Rate of disappearance of A. So once A term and this term both are equal, so for the first question, rate of disappearance, so the total both equal, make it equal. So what will be there? Minus 1 by 4 dA concentration divided by dt concentration equals to minus dB concentration divided by dt concentration will be there. Say dB minus dt concentration value, how much is given? So that is 0.25 molarity second inverse is mentioned. So now what they're asking in the question, rate of disappearance of A. So rate of disappearance ante idi maatrame vastundi, rate of disappearance. Clear? Understand all of you? So 4 when it is sent that side. So 4 when it is sent that side. Say, look at my dear students. Then rate of disappearance of A equals to, then so 1 by 4 when it is go that side, then so 0.25 into 4. 0.25 into 4, how much you can get? 1. So 1 molarity second inverse you can get. Clear? Then next one, rate of appearance of C, in case if you want to see. Second one, rate of appearance ante, so this is C. So if two equal, right? So then rate of appearance of C, in case if you want to take, then so rate of appearance equals to dC divided by dt have to take. So dC divided by dt is required, then 1 by 2 when it is sent that side 2. So 2 into you can get what? dB divided by dt, right? So dB divided by dt you can get. So dB divided by dt, what will be there? So this is the value for dB divided by dt. So 2 into then 0.25 you can get 0.5. So 0.5 molarity, then second inverse. Understand, my dear students? So this is the question. Yes, note down the question with answer. So next we will discuss one more question. Yeah, so one of the question I will give as a homework to you people. So note down the question, all of you. That is same type of question. So what we are discussing now. ఇప్పుడు ఏదైతే డిస్కస్ చేశామో అలాంటి టైప్ ఆఫ్ క్వశ్చన్ మీకు ఇస్తా ఉన్నా. సో దాన్ని మీరు హోంవర్క్గా చేసి దెన్ యూ కెన్ ఆన్సర్ ఇన్ ద కామెంట్ సెషన్. సో దట్ ఈస్ థర్డ్ క్వశ్చన్. ఫార్ the reaction 2a plus b, for the reaction 2a plus b gives rise to 2c plus 3d. The rate change in the concentration of C is the rate change in concentration of C is 1 molarity second inverse. Calculate the rate of reaction, rate change in the concentration of. Calculate the rate of reaction ROR and rate changes with respect to A, B, C, D. They are mentioned like this. Already with respect to C is given. Then, so A, B, D. Just to take it as A, B, D. That's it. So, meeku question lo artham kavalsindi first. So, reaction తీసుకోవాలి. Reaction ఏమున్నది? So, that is 2A plus 2A plus B gives rise to 2C plus 3D is there, right? సో దీనికి రేట్ ఆఫ్ రియాక్షన్ మెన్షన్ చేయాలి. రేట్ ఆఫ్ రియాక్షన్ మెన్షన్ చేయడం అందరికీ వస్తుంది. సో దట్ ఈస్ -1/2 ఇంటూ dA కాన్సన్ట్రేషన్ డివైడెడ్ బై dt, దెన్ ఈక్వల్స్ టు మైనస్ dB కాన్సన్ట్రేషన్ డివైడెడ్ బై dt, దెన్ ఈక్వల్స్ టు 1/2 ఇంటూ dC కాన్సన్ట్రేషన్ డివైడెడ్ బై dt, దెన్ ప్లస్ ప్లస్ 3D కాన్సన్ట్రేషన్, దట్ ఈస్ 1/3 ఇంటూ D కాన్సన్ట్రేషన్ డివైడెడ్ బై dt. Like this you can get. See here, so one of the term with respect to C is mentioned, change in the concentration of, that is 1 molarity second inverse, nothing but, so that is change in the concentration, nothing but rate of appearance, product called rate of appearance of C mention chesadu. Rate of appearance of C ante D concentration of C divided by dt, it is equals to how much is given? 1 molarity second inverse is given. అంటే సో ఓన్లీ దిస్ వాల్యూ ఈజ్ మెన్షన్డ్. సో రేట్ ఆఫ్ రియాక్షన్ ఫైండ్ అవుట్ చేయాలంటే రేట్ ఆఫ్ రియాక్షన్ ఈక్వల్స్ టు 1/2 ఇంటూ విత్ రెస్పెక్ట్ టు దిస్, దెన్ dC డివైడెడ్ బై dt you can take. So 1/2 into 1 you can get what? So 1/2 only. So 1/2 molarity second inverse you can get the rate of reaction. Then one more, what they are asking, rate changes with respect to A, B, D. అంటే రేట్ ఆఫ్ డిసపియరెన్స్ ఆఫ్ ఏ, రేట్ ఆఫ్ డిసపియరెన్స్ ఆఫ్ బి, దెన్ రేట్ ఆఫ్ అపియరెన్స్ ఆఫ్ డి, ఆల్ దీస్ యూ హ్యావ్ టు ఫైండ్ అవుట్. ఓకే, సో ఫైండ్ అవుట్ చేయండి. ఆన్సర్స్ ఏంటి, ఏబిడి చేంజెస్కి ఆన్సర్స్ ఏంటో కామెంట్ సెషన్లో ఎక్స్ప్లెయిన్ చేయండి. దెన్ థ్యాంక్ యూ వెరీ మచ్.